Here we learn the sign convention for reflection of spherical mirrors. The first sign convention is object is always placed to the left of the mirror. Here we have a concave mirror. And in this concave mirror, the object is always kept to the left. This is the left of the mirror, this is the right of the mirror. We never keep the object to the right. This is wrong. We always keep the object to the left of the mirror. Here we have the convex mirror. And like we said, the object is kept to the left of the mirror. And of this mirror, this is the left and this is the right of the mirror. And the object will always be kept in front, in the left of the mirror. It is never kept behind the mirror. So here is the object, which means when the rays of light come in, they always come from the left hand side of the mirror. So when the rays, we draw any rays, we are drawing it from the left hand side. This is the direction of the incident light or the incident ray. They are coming from left to right. Here too, from left to right of the mirror, from left to the right of the mirror. So remember, when you're drawing the object, always draw it on the left hand side of the mirror, not on the right hand side. This is the first convention. The next convention is all distances parallel to the principal axis are measured from the pole of the mirror. First, let's denote the pole of the mirror. The pole of the mirror is the middlemost point of the mirror. So here is a pole, and in this case, this is the pole. Let's name the kind of mirrors. Here we have the concave mirror. This is the convex mirror, bulging outside. Now we have done the pole of the mirror. Now let us see what is the meaning of principal axis. For principal axis, first we have to denote or mark the center of curvature. So this is the center of the mirror, center of curvature, and the line that passes through the center of curvature and the pole is called the principal axis. So here is the principal axis. For the convex mirror also, first we have to see the center, which is C, and the line that joins the pole with the center of curvature, this line is called the principal axis. Now they say all measures are to be made from the pole of the mirror, which means if I have an object kept at this point, here is the object, and I want to measure the object distance, I would have to measure from the pole, this is the pole, to this. This would be my object distance. Again, in the next diagram, if the objects are always kept on the left side and we want to measure the object distance, first we denote the pole, and from the pole, this distance right up here will be the object distance. If the image is formed behind the mirror, suppose here is the image. How do we calculate the image distance? How do we measure the image distance? From the pole. So this here is the pole. This would be the image distance. Measure from the pole. Also here in this mirror, if the image is formed on this side and I want to denote the image distance, is measured from the pole. So from the pole I measure, this is image distance. So all distances parallel to the principal axis are measured from the pole. So to repeat, we measure all distances from the pole, maybe to the left or to the right. Here also maybe to the right, to the left. All distances are measured from the pole. The next convention, all distances measured to the right of the pole are taken as positive, and the distance measured to the left of the pole are taken as negative. So again, here we have the two mirrors. This is the concave and convex. Here we have the left and the right. This is the left and this is the right. Now they said all distances measured to the right. So if I take this measure, if I measure from the pole in this direction, it is taken positive. However, if I measure from the pole in the left direction, it is taken as negative. Same here. If I measure from the pole towards the right, it is taken positive, but if I measure from the pole towards the left, it is taken as negative. Let's now apply this in real and virtual images. So here you have the concave and the convex mirror. This is the principal axis. Here is the principal axis. Now if the object, we know the object are always placed to the left. That was the first rule, that the object is always placed in the left. So this is the object and here is the object. It has to be placed in the left side of the mirror. That means the object distance is a distance between the pole and the object. This will be the object distance. And see, when we measure object distance, we are going towards the left. We are measuring towards the left. So object distance here will be negative. And we call object distance as u. It will be minus, negative. In this case also, the object is always kept to the left, and when we are measuring object distance, we measure from the pole to the object, and we are always going towards the left to measure object distance. So here also object distance, which is denoted as u, will always be negative. So remember, object distance is the distance between the pole and the object, and it is always negative in concave as well as in convex mirror. So I repeat again, u, which is object distance, always negative. You need to remember this point because it is always kept to the left, and we measure object distance here towards the left. We go from the pole to the object towards the left, from the pole to the object towards the left. Everything that goes towards the left is measured negative. We'll now talk about real images and virtual images. Real images are images where the rays actually meet, and in a mirror the real images will always be formed on the left side. So this will be the real image, always on the left side because the rays actually meet. The virtual images will be formed behind the mirror. So here will be the virtual image. This is the real image. So when it comes to real image, what is going to be the image distance? Now we know, again, we have to measure, in this case we have to measure from the pole to the image, and we are going to the left, so this is going to be negative. So for real image, the image distance, which is denoted as V, equal to always negative. Like even if we come to the next case, convex mirror. In convex mirror, of course, real images are never formed. So there is no case of real image. But in concave mirror, we have both real as well as virtual image. Now when it comes to virtual image, see, it is formed on the right side. So when we are calculating image distance, we measure from the pole and we go towards the right. So it is positive. So virtual image, for virtual, the image distance is always positive. Even when we come to the next case, in convex mirror, the virtual image is always formed behind the mirror. And if we want to measure the distance, we measure from the pole, we measure in this direction, we go towards the right, and hence it will be positive. So in virtual image, the image distance is always positive. Real image, the image distance is negative. Now let's see the sign convention for the focus. First is the concave mirror, and in the concave mirror we know rays that are parallel, all these rays that are parallel, after reflection they will all meet at a point on the principal axis, which we call the focus. Rays parallel to the principal axis, after reflection they meet at this point on the principal axis, and we call this point as the focus here. And the focal length is the length between the pole and the focus. But now while measuring the length, we are going towards the left. This is the focal length. This PL is the focal, PF is the focal length. And we have to measure, we are going to, it's to the left of the pole. So in concave, focal length is negative. But when we come to convex, here again rays that are parallel to the principal axis, after reflection they appear to come from a point which is called the focus. So they appear to come from this point. So we see the focus for convex is behind the mirror, and to measure the focus we have to start from the pole and go to the right. This is how we measure the focus. From the pole we go to the focus and we go to the right, and hence the focus will be positive. So focal length in convex mirror is positive. So you got to remember this. Distances measured perpendicular to and above the principal axis along the y-axis are taken as positive, which means if the image is in the upward direction, the height of the image will be measured from the axis upwards. This will be the height of the image, and since it's measured upwards, it will be taken as positive. But if the image is inverted, it is below the axis, below the principal axis, to measure this you have to go below in the downward direction. This would be taken as negative. So all images that are erect, what are erect images? Which are above. This is an erect image, right? So for the erect image, your H will be always positive. And remember, who are erect image? Virtual images are erect. But images that are inverted, which are downwards like this, inverted image, to measure them we have to go down, so the H will be negative, and inverted images are real images. So for real images your H or height will always be negative. So this is a point you need to remember. So for real images are always inverted, and hence the H is negative. But virtual image, they are erect and the H is always positive. This is the second point. We have not read it, but we've already discussed it. Distances measured to and below the principal axis along the y-axis are taken as negative. So whatever you measure below the principal axis is taken as negative, and whatever is above is taken as positive. So we have the principal axis here. Whatever you measure above is taken positive, and whatever you measure below is taken as negative. We'll now summarize the sign convention. So here is the mirror, and we have seen everything that is towards the right is positive. Things measured upwards is also positive. Distances measured to the left are taken as negative, and distances measured downwards are taken as negative. And here is the direction of the incident ray, which means the objects are always kept on the left side. Here, object is always on the left. And I prefer to remember the sign convention on a graph. You keep the imagine your mirror is on this y-axis. So here is the mirror, and if you see, you always start measuring from the pole, your origin here, this is your pole, and whatever you measure from the pole towards the right will always be positive, because it is in the positive part of the x-axis, and from the pole whatever you measure to the left, comes to the left, is negative, will be negative, because it is in the negative side of the x-axis. Again, whatever you measure above will be in the positive, so it will be positive. It is the positive part of the y-axis, and whatever you measure below, downwards from the x-axis, will be taken as negative. So let's try to figure out what is the focal length of the concave and convex mirror using this graph. So we know, I always told you, we consider the axis to be on here, the mirror to be here, and if you are taking the concave mirror, here this would be the concave mirror, so this would be like your reflecting surface, and for the concave mirror, you know your focus is always formed in front of the mirror, this side, here, and this would be your focal length. From the pole, this would be your focal length, and you will definitely agree the focal length is in the negative, so it will be negative. So concave mirror, focal length is negative. But when it comes to convex mirror, we know the focal length is virtual, it comes on this side, the focus, here it comes here. So the focal length will be measured in the positive part. So for convex mirror, this is for convex, it will be positive. As we do the numericals of the chapter, there are certain terms we need to know, and one is magnification. So the magnification is always given as a ratio of height of the image, which is always denoted as h dash, over height of object, which is denoted as h. So we write magnification m, which is h dash over h. Now, magnification can be also expressed in the form of object distance and image distance. So magnification is also equal to image distance, which is v, over object distance, which is u, and there's a negative sign that you have to remember. And we have the mirror formula, and the mirror formula is 1 over v, which is the image distance, plus 1 over u, object distance, equal to 1 over f. F is a focal length. So here also again I'll write, remember magnification is minus v by u, and it is also image over object.